Hello, boys and girls, and welcome to Valence Electron Notes. Don't let the term valence electrons scare you. It is something that is very easy to understand, and if you don't get it the first time, you can definitely watch this video a couple of times. I'm Mr. Langley. If you do have any questions at the end of this video, make sure that you talk to your science teacher. So here's what we're looking for today. We are looking to make sure that you understand that valence electrons determine an element's chemical properties and reactivity. We'll really talk more about chemical reactivity later on, but what we're first going to talk about is what are valence electrons. Okay, so here we go. Valence electrons. An electron is the an electron in the outermost shell of an atom that can participate in forming chemical bonds with other atoms is a valence electron. So remember, right here in the middle, we have the nucleus. That is made up of protons and neutrons. Protons and neutrons are here in the nucleus. And zipping around the outside are where the electrons are. The electrons are sort of like little moons going around this nucleus here. They never actually touch the nucleus. The first energy level, or some people call it the electron shell, the first level, the first ring, the first orbit can hold only 2 electrons. I know that you might be thinking, hey, Mr. Langley, right in here, there's a bunch of space here and a bunch of space here. We could put a bunch more electrons. I know it seems that way. It just doesn't work that way. So the first energy level, the first electron shell holds only 2. The second one can hold up to 8. And then when you fill that up, you have to add a third energy level, and that one can hold up to 8. Now you might be thinking, well, Mr. Langley, the first one holds 2, and that's all it can hold. Then we add a second one, and that can hold 8. So 2 plus 8 is 10 electrons so far. Then we fill that up, we go to a third one. It can hold 8. You might go, well, Mr. Langley, there are only 5. 1, 2, 3, 4, and 5. Okay, so that turns out to be 15. So this is atomic number 15. It has 15 electrons, 15 protons, atomic number 15. Well, hey, Mr. Langley, you said it can hold up to 8. It can hold up to 8, but that doesn't mean it can hold, that doesn't mean it always holds exactly 8. In this case, it only needed 5, right? And you can look up, I believe that atomic number 15 is phosphorus, right? The number of valence electrons determines the element's reactivity. A valence electron is only the outermost shell. It doesn't matter how many energy levels, how many electron shells, how many orbits, how many rings there are. Whatever the last outermost ring is, that is the valence electron energy level, the valence electron shell. So this third one right here, not this one, but this one right here, this outermost third ring, that is the valence electron shell, the valence energy level. What if there were only 2 energy levels? What if we didn't need 15 electrons? What if we had only 10? 1, 2 on the first one, and then 8 on the second one. Well, if there were only 2 rings, then the second ring would be the outermost ring, so it would be the valence electron shell, or the valence electron energy level. The valence electrons are just the ones on the outermost ring, the last ring there is, okay? The more valence electrons an atom has, the less reactive it will be. In other words, the safer it is. Don't worry about how many are on this first ring. Don't worry about how many are on the second ring. Whenever we talk about valence electrons, you only look on whatever the outermost ring is, and in this case, it happens to be this third ring. How many can this third ring hold? It can hold 8. How many are on here? 1, 2, 3, 4, 5. So it's getting to be pretty stable, okay? It's getting to be pretty stable. The less valence electrons an atom has, the more reactive it would be. So if there were only 1 electron on this entire outer ring, if there were only 1 valence electron on this valence energy level here, then wow, it would be extremely dangerous. And you can look on the periodic table, that would be hydrogen and lithium and sodium and potassium and cesium and francium, or some people say francium. All of those are very reactive. They are very dangerous because they have only one electron on the outermost energy level, which is called the valence energy level. Reactivity of atoms, the ability of atoms to combine or separate with other atoms to create new substances. That is reactivity. It causes a chemical reaction. If you ever wonder about why things explode or blow up without any kind of fire, you know, you mix two chemicals together and they blow up, that is reactivity. Of course, that's going to happen only with elements that have lower valence electrons here. If it's completely full, we'll learn about this later. If this valence energy level is completely full, then it is an extremely safe element and it doesn't react even a little bit, not even a tiny bit. It does nothing. If this energy level, this valence energy level, the outermost ring, if it is completely full of electrons, then that element doesn't do anything at all. It's not even gonna make paper slowly turn brown over hundreds of years. It doesn't do anything. It doesn't react. Why doesn't it react? Because in order for an element to react with another element, it has to have an empty spot somewhere on this valence energy level. And if it's completely full, in this case, this third ring can hold up to 8. So if we had an element where this valence energy level here had 8 electrons in it, then there is no room for it to grab onto other elements and other chemicals and do anything. So it's completely safe. Valence electrons are the key to this chemical reaction process. Reactivity changes across the, oh, I gotta wait, it probably says periodic, yeah. Reactivity changes across the periodic table. I'll show you that more in a little bit. So atoms want to be happy. What does it mean that an atom is happy? It means it is stable. It means it doesn't react. Atoms want to be completely boring. They don't want to react at all. Having its outer energy level, the valence energy level, the outermost energy level, having that filled with electrons makes it stable. So it looks like this is going to want to pop this stuff up. I'm not going to be able to move my cursor very much, but if you take a look at this model of neon down here in this bottom corner, neon has 10 electrons. There are 2 electrons on this first energy level right here. I don't know if there's something popping up on your screen, but on my screen there's something popping up and it doesn't show the bottom. But right here, there are 2 electrons, one right here and one right down here. That's all the first energy level can hold. But neon has 10 electrons. So there are 2 on the first one, and then there are 8. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 on the second energy level. So 2 on the first plus 8 on the second, that's 10 electrons, and that's all the electrons that neon has. Now here's the question. Which one of these is the valence energy level? Well, not the inner one, it's always the outermost one, so it's this one here. This second ring can hold only 8 electrons, and it does have 8 electrons. That means it doesn't have any empty spots on it. It is completely full. I know it might look like some other electrons could fit in here. I know it looks that way, but they can't. Only 8 can fit on this ring, and there are 8, so it's completely full. What does that mean about neon? It means it is very stable. We call that happy. It's very happy. It does not react with anything else. Neon doesn't do anything with any other element. The only thing that neon can do is if you put it in a glass tube and remove all the other air and run electricity through it, it will light up. That's called a neon sign. And true neon is only red. There are some other gases that will glow other colors, and we call them neon, but they're not really neon. Neon glows red, and that's all it does. Neon is extremely safe. It doesn't do anything with any other element. Why? Because this outer energy level here is completely full. All 8 spots are taken up, so it doesn't have any empty room to grab onto other chemicals. Right here, let's take a look. This is the periodic table. These over here are very, very reactive elements right here. Hydrogen, especially lithium, sodium, potassium. Oh, I left out rubidium earlier. Cesium and francium or francium. These are extremely reactive. If you just toss them in water, lithium on down, if you toss any of these in water, they explode. You don't need a match. You don't need anything else. You toss it in water, it will explode. But as you move to the right, as you go across to group 2 and 3, 4, 5, 6, 7, they get less and less and less reactive. In other words, they get safer and safer and safer. All the way down, now hold on, you get to 16, 15, it gets safer, 16, it gets safer. And then at group 17, it spikes way up. And these get very reactive also because they all have one empty spot and it's easy for them to grab on. All of these have 7 electrons in their outermost energy level. And so it's very easy for them to grab onto just one more electron. And when they grab onto one more electron from some other element, they could explode. And then 18, group 18, these are the ones, every single one of these, helium on down, every one of these has no empty spots on their outermost energy level. They have no empty spots on their valence energy level, which means they cannot grab onto other elements. And if they can't grab onto other elements, then they can't do anything. So this last column here, group 18, these are called the noble gases. All of these are gases and they are extremely safe. They don't do anything at all. Nothing, nothing, nothing. They are extremely safe. My goodness, helium, it floats, and you may say, well, Mr. Langley, helium floats in a balloon, but that's not a chemical reaction. They don't do any kind of chemical reaction. Helium is so safe, they stick it in kids' birthday balloons, and doesn't give any reaction with any other chemical. All right, so just remember, over here in group 1, these are extremely reactive. All of these have only one electron in the valence energy level, the outermost ring. And then as you go across, they get safer, 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 until you get to 17. And then, woo, those are very dangerous. And then once you get to group 18 right here, these are very safe, okay? Remember 288, this first period, hydrogen and helium can hold only 2 energy level, only 2 electrons in that ring. Helium has 2 electrons, and that's the most that that first ring can hold. Helium has only 1 electron in its ring, and then helium has 2, and that's all it can hold. Then you have to go down and make a second period, period 2 right here. It goes across, and the most that electrons that can go on this second energy level, the second orbit, the second ring, are 8. So neon has 8 electrons in its outermost. Now it has 2 in the first energy level, the first ring, the first orbit, 2 in the first ring, and then 8 in the second one. So 2 plus 8 is 10. That's why neon has 10, atomic number 10. That means 10 protons, 10 electrons. So neon has 10 electrons, 2 in the first ring, plus 8 in the second. And then down here in the third period, the outermost ring can hold only 8 electrons also. It has 2 in the first one, 8 in the second one, and 8 in the third one. What is 2 plus 8 plus 8? It's 18. And argon has 18 protons, 18 electrons. 8 of those are valence electrons, okay? If you're a little bit confused, please talk to your teacher on that. So what do we have right here? Let's do a quick review. We have 1 proton and 1 electron. If it has 1 proton and 1 electron, then it's atomic number 1. There's atomic number 1 right there, hydrogen. So this is this is called a Bohr model. This is a Bohr model of hydrogen. What happens if an atom doesn't have 8 valence electrons? Well, in this case, hydrogen has only 1 valence electron. It can hold up to 2, but it has only 1. That means it has an empty spot just waiting to grab onto another electron from another element. Hydrogen does not follow the rule of 8. Its happy number, its stable number is 2. It holds up to 2 electrons. If it has 2 electrons, it is very safe, very happy. That's helium. If it has only 1, ooh, that's hydrogen. That's flammable. Who might hydrogen bond to make itself a happy or stable atom? Well, it could bond with itself. Take a look right here. This hydrogen atom has 1 electron, but it wants to have 2. This hydrogen atom has 1 electron, but it could hold 2. Look at this. When they get together, they bond. And here's what's going on. These 2 electrons can zip around this orbit, which makes it all nice and happy, but they also zip around this orbit, which makes it happy. So they are sharing atoms, these atoms are sharing electrons, 1 electron from this atom, 1 electron from this atom, but they are sharing, so now it's like they're doing double duty. There are 2 electrons here, and the 2 electrons go around here, almost like a figure 8, and they are keeping each other happy. Let's take a look at oxygen. Here, how do we know this is oxygen? Well, we count up the electrons. There's 1, 2 on the first energy level. Let's go to the second energy level. 3, 4, 5, 6, 7, 8. We have 8 electrons. Let me do that again. 1, 2, 3, 4, 5, 6, 7, 8. If we have 8 electrons, that means it is atomic number 8 right there. Atomic number 8, oxygen. Okay, oxygen. So this is oxygen. Oxygen has 6 valence electrons. You may say, wait, Mr. Langley, I thought you said that oxygen has 8 electrons. It has 8 total electrons, but it has 6 valence electrons. That means 6 on the outermost energy level. 1, 2, 3, 4, 5, 6. Now this outer energy level, this valence energy level here, can hold up to 8, but it has only 6. That means it's got 2 empty spots. It needs to bond with 1 atom that either has 2 valence electrons, and that'll get it to 8, or it needs to bond with 2 atoms that have only 1 valence electron. You're trying to get to 8. So if we already have 6, it needs 2 more. Well, how can it do that? Hey, look, it can bond with a hydrogen here. This electron is part of this hydrogen atom, and this electron over here is part of this hydrogen atom, but they fill in the 2 empty spots here. So let's count. We have 1, 2, 3, 4, 5, 6, 7, 8. Now there are 8 electrons on this valence energy level right here, this valence orbit. This one actually belongs to hydrogen, but it is sharing it with oxygen. And oxygen, this one belongs to oxygen, but it is sharing it with hydrogen. Remember, hydrogen wants to have 2, but it only has 1. So oxygen is saying, it's almost like shaking hands. Oxygen says, hey, I'll let mine go into your orbit, and you let yours come into my orbit, and they share. It's going around and around and around and around. And same thing over here. This green one, they're not really green, but this green electron right here really belongs to hydrogen, but it's filling in the empty spot on oxygen, and this oxygen electron right here is filling in the empty spot for hydrogen. So they are sharing right here, and they are just zipping around. Woo! Not quite like that, but sort of. This is called the Mickey Mouse molecule. It looks sort of like Mickey Mouse. What is this? We have 1, 2 hydrogen. Well, that's H2. And then we have 1 oxygen. That's O. So it's H2O. We have 2 hydrogen, 1 oxygen, H2O. That's something called water. W-A-T-E-R. And you need it. Okay? All right. This can be a little bit difficult to learn over a video. It's a lot easier when you can see your teacher demonstrate this on the board. So if you are a virtual learner, make sure that you talk to your teacher if you don't fully understand this. Go back and watch it, but the main thing to remember is the valence electrons are the electrons in the outermost energy level, whether it has only 1 energy level or 1, 2 energy levels, or even 1, 2, 3 energy levels. If there were a 3rd one here, whatever the outermost energy level is, that is where the valence electrons are. If there is only 1 energy level, it wants to hold 2 electrons. If there are 2 energy levels or 3 energy levels, that 2nd or even 3rd energy level wants to hold 8 electrons. Okay. If you have any questions, please talk with your teacher, and This ends the lesson. Thank you.